Hello, ninth grade. Let's recap what we were learning the other day. So this is the start of that handout. It's a PDF in the Google Classroom. You can also print it out or just do work in your notebook, and I'm going to do it with you. So to start with vector A, let's think about direction. That's 2 spaces to the right and 4 spaces up. So as I get my vector tool out, I am going to draw that vector from this left corner. I'm going to go 2 spaces to the right and then 4 spaces up. And that is vector A. Now vector B is a little bit bigger. Notice the values increased. So we're going to go 3 spaces to the right and 5 spaces up. So I'm going to start it right here and go 3 spaces to the right. 1, 2, 3, 4, and 5. Now, if you have graph paper, awesome. You can do it on graph paper. But if you don't have graph paper, you could pause this video and open open Desmos.geometry. And I will type that so that you know what I'm talking about. If you type this in your browser, it'll pull up a graph for you to draw vectors. Okay, let's keep going. Vector C is a horizontal vector, 2 spaces to the right. So there is vector C. And I think I should make an adjustment because it's a little bit slanted. It should have it literally a slope of 0. There's just flat line, flat vector. Now vector D is 3 spaces in the south or down direction. So this one, I'm just going to go 3 spaces down. And there's vector D. Let's keep going. Vector E is the left and up. So I'm going to go over here so I have some space to go left. So 2 spaces left and 1 space up. There is vector E. Vector F is 4 spaces to the right and 2 spaces down. So 4 spaces to the right. Oops, I went 5. This should be 4. And then 2 spaces down. And that is vector F. Whoops. The last 2, vector G, is 3 spaces to the left and 4 spaces down. And that is vector G. H is 4 spaces to the left and then 5 spaces up. 1, 2, 3, 4, and 5. I'm going to adjust that. I'm going to move that vector. Just like on the Desmos, you can move your vectors. You just need to make sure that when you move it, that it's the same size. So we needed to go 4 spaces to the left and 5 spaces up. So let's make sure. 1, 2, 3, 4, and 5. And then this just needs to come up to the corner a little bit. There we go. And that is vector H. And again, G was -3, -4. The next thing I want us to look at is writing vectors. So writing it in this notation, using those less than and greater than symbols, kind of like an ordered pair. So let's first trace. And the direction is critical. So be very mindful of the direction. So this first one, A to B, we start at A and then we go up to B. So we moved 4 spaces to the right and 1 space up. So that is why AB is vector 4, 1. Now, the next vector, B to C. Let's trace that vector and see the direction. So from B to C, we're going to the right 2 spaces and down 3 spaces. And so that's why vector BC is to the right 2 and down 3, or 2, -3. Let's keep going with CD. C to D is going in an opposite direction. It's a negative direction. We went to the left 6 spaces and down 1 space. So that's why vector CD is -6, -1. Let's keep going. D to A. And if you feel like a challenge, feel free to pause the video and do them on your own, and then unpause and see if you are correct. So from D to A, be mindful of that direction. We are going up. So that is why vector D to A is 0, 3. Now, B to A is just the opposite of AB. Well, what's the opposite of 4? What's the opposite of 1? If you were thinking -4 and -1, you are correct. So -4, -1 is the vector B to A. And we can definitely trace that to see from B to A, we have gone down and to the left, or to the left and down. Let's keep going. A to C. So we need to draw a vector from A to C. Let's draw that more precisely. So from vector A, C. It's like the diagonal of that quadrilateral. And that diagonal is to the right 6 spaces and down 2 spaces. So vector AC should be +6. Ooh, Miss Paulson made a typo. Hope you noticed it before me. To the right of 6 and then down 2. Okay, 2 more to go. Let's look at B to D. Let's draw that diagonal in. So from B down to D, that is to the left and down. That's to the left 4 spaces and down 4 spaces. And so that's why our vector is -4, -4. And lastly, if we started at A and ended at A, have we moved? Of course not. So this, oh, why do I have a negative there? 0 is just 0. It's not positive, it's not negative, it's just 0. So this would be our vector from A to A, because you haven't moved anywhere. Excuse that interruption. Okay, the next thing I want us to look at is finding the magnitude. I'm going to go through these 4 examples, and then I encourage you to look at the other 8 practice parts. So let's take a moment and adjust our presentation here so that you can see my work on my notebook. If you need to pause the video to get out your notebook, please do so. So to find the length of A, we have the vector 5, 2. If we drew that in a triangle, this would be the 5 and this would be the 2. So we need 2 squared plus 5 squared equals that C squared. That C is our vector length. Not the C squared. Notice C is the vector length. Let me zoom in a little bit more. Okay, now let's do the order of operations. We've got 2 squared, 5 squared, and that's equal to C squared. So C squared is 29. That means C is the square root of 29. Leave that alone. We don't need a decimal. Don't do the extra work of rounding. Leave it as an exact value. Now, looking at B, we have the vector 3, 1. And if I am moving too fast for you, please pause the video as you need it. So this triangle would be 3 spaces to the right, 1 space up, and that would be our vector length. So 1 squared plus 3 squared will give our magnitude squared. So this is 1 plus 9 is the C squared. So C squared is 10. So that means the vector magnitude is 10, or excuse me, square root of 10. In part C, we have negative directions. We have the vector -4, -2. And so that vector, we're going to go to the left 4 and down 2. So this would be what the triangle looks like. I forgot my right angles. So 4 in this direction and 2 in this direction. If we add the vectors, we see that direction. So when we square that -4 and square that -2, we're going to have positive values because we know distance is always positive. So -4 times -4 is a positive 16, and -2 times -2 is a positive 4. So C squared is equal to 20. Oh, this is going to be fun. Now, the magnitude is the square root of 20. But guess what? We can simplify that further. The biggest perfect square that goes into 20 is 4. So the magnitude is also the square root of 4 times the square root of 5. Well, what's the square root of 4? 2. And so the exact simplified magnitude is 2 root 5. One more example that I will do over here on the right side, D, is vector 3, 0. Anytime you have a 0 in the vector, you're really only you're finding this distance. If we've gone 3 spaces to the right and nothing up and down, we really don't need the Pythagorean theorem. The distance is simply 3 units. You can add that there. But just to show our work, it would be 3 squared plus 0 squared is equal to c squared. So this is 9 is equal to c squared, and we know the square root of 9 is 3. So c is 3. I am going to zoom out so you can see my whole notebook. I will take a picture of it. So that you can have this to view. Sorry if that startled you. If you need to pause the video to examine those 4 examples, please do so. Thank you for watching.